When we determined on number 3 whether or not this sequence here converged, when we took the limit, we basically used relative growth rates, which brings us to example 4. Compare the relative growth rates of 2 to the n and n factorial. In other words, which one of these things grows faster? Well, here, I've got a table of values for you. And you can see that the exponential one is initially bigger. It's bigger than the factorial, but it's not long before the factorial overtakes it, and then by a very, very large margin. So as we're approaching infinity, the factorial is going to be the very clear winner. Here, let's take a look on our graphing calculator here at these things. So my calculator, let's pull up a graph one, and let's see, what do we got? We got, let's say we do the same one that was there. It was 2 to the x power, nth power, whatever. Okay, so there's a graph of that one. And then I can also do this as a factorial. Now, a factorial, though, is discrete. So whenever I do x factorial, it's going to look weird on the graph. You can see probably a whole bunch of nothing except for some dots, right? That's what you're going to see. And it's hard to see the actual dots, individual dots here. So I think I can add in a table here. So yeah, table, split screen table. So you can see these, and these are the numbers that we had over there on the slideshow. And you can see right about here, after this number, it kicks over here into scientific notation because the numbers get so large. Just compare these two side by side, right? Gargantuan, yes, so factorial grows way faster than exponential. And it doesn't just have to be 2 to the n. Let's see if I can just change this function. Let me come back over here. Let's change it to something else. Can I scroll over here? Come on. Yeah, scroll over and let's make this 2. Yeah, I don't know, but how about an e? Yeah, that's good. E to the, oh, that, yeah, that's crazy. I'm gonna have to delete some of this stuff up. Okay, so now put that and then put the x. There we go, and then enter. All right, our numbers, of course, were bigger when, slightly bigger than when it was 2, because we're starting with something that's a little bit bigger than 2. But still, all right, if I go into one of these at 12 and compare these two numbers, you can still see that factorial is the winner. Hey, let's try maybe 10. Maybe 10 is going to grow faster. Okay, all right, so again, I think I had to remember just delete out the whole thing because, yes. Oh, there was a 10 to the box right there. I could have just used that, but I didn't. All right, so enter. All right, so yeah, look at this 10 to the x. Wow, that's bigger, right? Okay. The sixth one, it's way bigger. And then here, let's look at the 11th one versus this one. Okay, so the 10 to the x is still bigger. This is, what is that, like 1 times 10 to the 12th power versus this one here. It takes a little bit longer for the factorial to overcome, but eventually it does. Right, okay, so here, this would be a good one. No, that's to the 18th. Where the heck does it overcome it? All right, so here we go. So here you can see this is times 10 to the 30th power, and this is times 10 to the 29th power. And right before it, oh yeah, it still overcame it before then. So someplace right in here is where the x factorial started overcoming the exponential. And this is always going to happen. But as that number, this base here, this 10 gets bigger and bigger, bigger, it just might take a little bit longer. But remember, we're going to infinity, so it's kind of okay, right? All right, well, this brings up maybe a natural question here. What about x to the x power? Hey, that's crazy. Now, let's come back over here. Let's compare those then. Delete out all of this and then put x to the x power. So I don't know if you've ever graphed this before, but it's crazy. Boop. All right, it does something super crazy like right here. And the reason why it does is because you're going to sometimes have some imaginary numbers. And then you can see that it shoots off to infinity rather quickly. So let's compare like number 24. That's 2 times 10 to the 33rd power. And this was to the 23rd power. Wow. All right, and this one, the 38th power, and this one, 28th power. Okay, here, let's come all the way down here to 40. On the 40, this is to the 64th power versus 47th power. So this factorial in this case, it never overtakes this x to the x power. It's rather crazy. Luckily, that's not something that you ordinarily have to do calculus on. Anyway, which brings us to some conclusions here about relative growth rates. So we're going to say that n factorial grows much faster than 2 to the nth power. So whenever we're taking some sort of limits, if we have the n factorial on the top is growing faster than the bottom, we're going to say that limit approaches infinity. But if these are reversed, we have the n factorial on the bottom, we have a bigger number on the bottom, then the limit of that sequence is going to approach 0. And these factorials, they often come into play with our sequences, as you're going to see. Okay, but it's not just, as we saw from the calculator exploration, it's not just 2 to the n. It could be any base, any non-variable, any constant base, still going to hold true since we're going to infinity. It may take longer for the factorial to overtake the exponential, but it will eventually overtake it. Okay, so then determine whether or not this sequence converges, and we have 2 to the n over n factorial, so it's just taking the limit as n approaches infinity of 2 to the n over n factorial. Relative growth rates say that the n factorial is going to grow faster, therefore this is going to approach 0, and check, it does in fact converge. The terms of the sequence converge to 0. Now, you could use L'Hopital's rule on this one, since it is essentially infinity over infinity, but you have to wrap your head around what is the derivative of n factorial, which is super crazy, and it involves something called the gamma function. If you're brave enough, you can look that up on the YouTubes or on your favorite math website, like, I don't know, maybe Wolfram Alpha or something like that.